After understanding what do we mean by constant speed and constant velocity, now it's time to look at something which we call average speed and average velocity. So let's say when we say that the car is moving with a speed of 40 km per hour, right? It is likely that the car is not always moving with the same speed, right? So suppose we are going from A to B. It might happen that sometimes the car is actually moving at a higher speed, let's say 50 kilometers per hour. At times, it must be starting from zero speed and sometimes moving at like 10 kilometers per hour. So sometimes it could be higher, sometimes it could be lower. But we are not interested what happens in between, but we just want to know on an average what happened between A and B. So we can simply say that the average speed, so V average is simply how much is the total distance traveled. So we are going to say total distance, and then we divide it by the total time it took to travel that distance, and we are going to call it an average. So on an average, how much time it took and how much distance is traveled, and that ratio of distance by time is what we call average speed. Okay, so we are not concerned what happened in between, but we are just looking at the total distance and total time. Instead of distance, if I put over here total displacement, and divided by total time, what do we get is average velocity. I can see here that I put a vector sign over top. So this is our average velocity, and this is our average speed. Fine. As we know, the displacement has two components. So if we take, for example, this one, let's say this is around 20 kilometers, right? So we'll put simply 20 and whatever time it took over here. But when we talk about displacement, it has two components. So we'll say 20 kilometers with the direction. Now from A to B, if it is going, we'll say eastward. Okay, so we have to provide both the information, which is the magnitude, the direction, and we divide by time. Basically, what we get is a velocity, which will also have both the things, magnitude and direction. So average velocity is going to be a vector quantity. Average speed is a scalar quantity. It does not have any direction. We are just looking at what the rate of that travel is. The best way to understand this is to look into few problems, and that will clarify how it works. So let's straight away go to few questions. So this is one of the question which says A, B, and C are 3 points in that order, which means they are in sequence A, B, and C on a straight road with AB is equal to 40 kilometers and BC is equal to 90 kilometers. I'm going to draw a small little figure here. This is point A. From here to B in sequence we go. This is given to be 40 kilometers. Fine. And from B to C, which is almost more than double of it, so I'll go all the way here. This is 90 kilometers. Now, a woman travels from A to B at 10 kilometers per hour, so she's traveling with a constant speed, as you can see. And then from B to C at 15 kilometers per hour, this is also a constant speed between B and C, right? What we have to find out is time taken to travel from A to B. That's pretty straightforward. We are looking for the time. We can also do it by using our equation for the speed and distance, which is going to be S is equal to Vt. We want to find this one. So T is going S by V. We have to ensure that S and V are in the same unit, which happens to be the case here. S here is 40 kilometers and the V here is 10 kilometers per hour. So the hour will go upstairs and this will cut and this will give us 4 hours. Okay, so time to travel from A to B is 4 hours. That will be our answer for number 1. The time taken to travel from B to C, very similarly we can do that. Time to travel from B to C, the distance is 90 kilometers divided by 15 kilometers per hour. So I'll go upstairs. So this is going to be 6 hours. Right, so this is the time taken to travel from B to C. Now it's asking me to calculate what is the average speed of the woman from A to C. As we say, the average, when we are talking about, all we care is the total time and total distance. Okay, so let's find that out. So the average speed is going to be total distance traveled divided by total time. We do not care what happens in between. So here the total distance, as you will see, is 40 plus 90. That's going to be 40 plus 90 kilometers. And the total time here is 4 hours plus 6 hours. So that's 10 hours. So this is going to be 130 by 10 kilometer per hour. Okay, kilometer per hour. So this will cut and our answer will be 30 kilometer per hour. Okay, as you can see, the women was traveling with like 10 kilometer per hour and 15 kilometer per hour. But on an average, all the way from A to C, she travels with an average of 13 kilometer per hour. And that is what we mean by average. We don't care whether she stops or change speed and so on and so forth. Now let's look at another one. A man walks 400 meter due east in a time of 190 seconds and then 100 meter due west in 50 seconds. Okay, so we'll always draw a diagram. So we're going to start from A, we'll walk 400 meter, okay, 400 meter towards east. So like this, and time it took is 190 seconds. This is in meter, this is in second, that's fine. And then 100 meter due west, which means the guy turns around and walks 100 meter due west. You see, I'm putting an arrow here, and this is our location C. Now we have to find his average speed. Okay, so average speed, V average is going to be total distance divided by total time. So how much distance the man has actually covered? So he went from A to B. We know that the distance is going to be path dependent, so we have tracked all along the path. So total distance from A to B, right? My S from A to B will be 400 meters, and S from B to C is going to be 100 meters. So total distance from A to C is going to be 500 meters. So we're going to put it over there. That's 500 meters. Now, how much is the total time? Total time from A to A to B is 190 seconds. And then from B to C says 50 seconds. I'll write that as well. So time from B to C is 50 seconds. So that's going to be 240 seconds. Okay. So we divide that with 240 seconds. We can cut, this is meter per second. So 0 will cut, and we are going to get something like 25 by 12. Okay, meter per second, which is slightly more than 2 here, right? Now we look at to find the average velocity, right? So average velocity, when we say V average with a vector sign, is going to be total displacement by total time. Now time is not going to change. So time we know is 240. So I'm going to put it over here, 240 seconds. We just have to find the displacement. Now displacement is very simple. Starting point to the finish point, right? So this is A is our starting point, and C is our finish point. We draw an arrow like that, and this is what it is. Now what is the length of this one? This is going to be 400 minus 100. So that's going to be 300 meters. So we are going to say 300 meters. We also have to provide a direction. Direction, as you can see, from A to C is towards east, right? So towards east. So now this is complete. Now we can cut this one. So we'll get 30 by 24. So that's going to be 5 by 4 meter per second eastward. Okay, so that's our average velocity, 5 by 4 and eastward. Okay, we are providing both the things here, which is the magnitude as well as the direction for the velocity vector, which is sort of in this direction only. Okay, so this is our velocity vector, 5 by 4 meter per second for the whole journey from A to C. Now let's look at another example which combines these 2-3 ideas. So that will really help us understand and clarify if we have any doubt. So the man wanted to pick up his wife at a bus station located 12 kilometers east from his home. So this is the home, and he's going to go 12 kilometers eastward to the bus stop. Okay, and this is 12 kilometer eastward. Okay, it took him 15 minutes to drive to the bus station. So from time, we are going to write over here, time from H to B is 15 minutes. A negligible time to pick up his wife, and then 20 minutes to drive back home. So he picks her up, and then drives back. Okay, this time in this direction, and the time from B to H, see how I'm writing for clarification, is going to be 20 minutes. So as we are reading the question, we are trying to visualize that through a small little diagram so that we can understand things in that context easily. Now it says, express your answers in the following question in terms of unit kilometer per hour. Okay, so it is asking for kilometer per hour. Our time is in minutes, so it will be wise to convert this into kilometers, hour. So 15 minutes is going to be 1 by 4 hours. Okay, and this one is going to be 1 by 3 hours. 20 minutes is 1 by 3 hours, and this 1 by 4 hours. Say, what was the average velocity, magnitude, and direction of the man during his trip to the station? Okay, so it is saying what is the average velocity when it's going from H to B to the bus station. So my displacement is going to be in this direction, right? So which is 12 kilometer east, and time it took from H to B is THB, right? Yes, so that is 1 by 4 hours. So this will go upstairs, so 12 into 4 is going to be 48 kilometers per hour. That's the magnitude, and then the direction is eastward. Okay, so this is displacement by time, and we can call it V average, right, from H to B. That's done with a magnitude of 48 kilometers per hour, and the direction is eastward. Okay, now what was the average velocity of his car during the trip back home? So we are doing other way around. Now look at how much is the displacement. This time the same distance, but the displacement this time is going to be 12 kilometer westward, right, from right to left, and the time it took going back from B to H is 1 by 3 hours. So 1 by 3 hours, 3 will go upstairs, it will become 36 kilometer per hour. This time it is westward. Okay, so we are providing the magnitude as well as the direction. So its average velocity is going to be 36 kilometer per hour westward while coming back from the bus station. Now final one, what was his average velocity of the car during the man's entire trip? Fine. So when he goes from home all the way to B and then comes back, how much is the displacement? The initial point and the final point is same, which means the displacement is 0, isn't it? So displacement here is 0, and the total time, whatever it is, 1 by 3 plus 1 by 4, we can simply say 1 by 4 plus 1 by 3 is also going to be 0. So its average velocity, with some miracle, is going to be 0 because final displacement is 0. Right, so this is how we simply follow the pattern and try to look for the exact formula, try to find out the components of those formulas, and we can simply do any question which is there, right? So I'll just quickly remind what we have learned in this class today is average speed. Okay, it's simply the total distance divided by total time, and average velocity is total displacement divided by total time, right? We have to ensure that whatever, if we are putting meter and second, the unit is going to be meter per second. If we are going to put kilometer and hour, it's going to be kilometer per hour, like that. So that's what we mean by average speed and average velocity.